This is our group member. We are given tasks to calculate and design water recirculation system, sewerage system, and also stormwater system. We picked Taman Kenanga Indah as our project location. The total houses there is 28 units, which give 140 PE. This is the location of our project that we gain from Google Map.
Okay, hi, I'm Azharuddin bin Masad. So it's my turn to presenting my part with the water recirculation. So I will briefly explain about the methodology and also about the result and analysis. Alright, first we start for the methodology. So there are three main elements that will be determined in the water recirculation system. For the first is determining the water demand. So in our project, there are single story terrace. Refer to the table water demand based on the type of the premises. There are 1,360 population equivalent liter per day. So we use the total PE to plan and manage their water resources because it's the PE for the development water demand. And then for the second, we have to determine the flow rates in pipes. In this project, we're using the Hardy-Cross technique to design the water distribution system for our housing project. And then we use the Hazen-Williams equation to calculate the head loss in each pipe based on the initial flow rates and the properties of the pipe and fluid. And then we have to determine the capacity and size of the water tank. So there are several restrictions and guidelines that must be considered when determining the water tank capacity and size. Especially we have to refer the guidelines for the span and also from the DID. And then we should comply with the acceptable values for each parameter and also take the consideration design to comply the requirement of a fire flow. Okay, next I will explain about the result and analysis for the water recirculations. Okay, as we can see at the slide, this is the detail of pipeline. So as we mentioned earlier in the project background, the location of study area was located at Taman Kenanga Indah Parit Raja. In this resident area was consists of the 28 units of numbers single story houses, and then for the average water demand 1,360 liters per day, and for the class of fire risk, so based on the Malaysian Water Association MWA guideline, so the fire risk for the residential building is class D, with the average total flow is 1,140 liters per minute. And then we using the type of pipe is the HDPE pipe. Okay, next, this is a proposed pipeline diagram. So as we can see, there are five main direction of our pipeline diagram. So started from the pipeline A to B, A to C, pipeline B to C, pipeline B to D, and the last one, pipeline from pipeline C to D. And for the each pipeline, they have a different length and also have a different size of the pipe. Okay, in this slide, I will show you in short how we determine the flow rate in each pipes. So first, after we create the detailed diagram of network, pipe network pipelines, and then we will use the equation of Hazen-Williams to calculate the head loss in the each pipe. So before we can calculate, we have to estimate the total water demand for Taman Kenanga Indah. So as we know, there are 28 units of houses and 1,360 liter per day of our average total water demand. So after we multiply with the two figures, we get 3,000 liter per day. And then we plus with the fire flow with 1,140 liter per minute, and then we get 1.6 million liter per day. So after we complete the calculation, we consider all the requirements and the guidelines. So as we can see at the figure at the right slide, there is the final result for the flow rate in each pipe that we get after we complete the calculations. Okay, next I will presenting about the determination of the storage capacity and also the size of water tank. So in this slide, this is the detail of water tank. So for this project, we propose is one unit water tank, and then for the water distribution system is gravity and pump combinations. And then for the average water demand, also the total water demand as I mentioned earlier. So and then for the type of water tank, we use the fiberglass reinforced plastic FRP tank. Okay, this map show the proposed water tank location. So, and also we can see there are existing tapping pipe was located at near in our project area. So for our proposed water tank will be connected to the existing tapping pipe, which has a pipe diameter of 300 mm and a pressure head of 55 meter ODL. So it's where the water supply comes from. Okay, next we determine the capacity of water tank. So consists of the two types of tank. First is the suction tank and the second is service tank. So in this slide, this is the calculation for the capacity of a suction tank. So as we know, the capacity of the suction tank storage is one-third from the total water demand. First, we have to calculate the volume of suction tank, which have to multiply the total water demand with the one-third, and then we get the 559,000 liter per day, and then we assume the dimension of the suction tank with the 24 meter width times 24 meter length and times 3 meter height, and then we get the volume of tank is 1.7 million liter. So as a result, the proposed dimension are acceptable because the volume of tank is more higher than the volume of the suction tank. Okay, next we calculate the capacity of a service tank. So the capacity of the service tank storage is two-thirds from the total water demand. First, we calculate the volume of suction tank. We multiply two-thirds with the total water demand and we get the 1.1 million liter per day. And then we assume the dimension of the service tank for the 20 meter width times 20 meter length and times 3 meter height. And then we get the volume of tank is 1.2 million liter, and then as a result, the proposed dimension is acceptable because the volume of tank is more higher than the volume of the suction tank. Okay, that's all from me. And then for the next slide and for the discussion and the conclusion, I will pass to the Iskandar. Thank you very much.
Assalamualaikum and hi, my name is Muhammad Faisal Irwan bin Mokhtar and now I want to present for the sewage system. So we decide to make 3 manhole for our project, our design. Total PE in our project area is 140, then we divide in 3 area. So manhole 1 to manhole 2 population equivalent is 80. Dry weather flow is 0.21. Peak flow factor is 6.21. Diameter sewer is 0.25. And area is 0.49 meter. Rated perimeter is 0.79 meter. Hydraulic radius 0.62. Gradient is 0.007. Velocity we got 1.07. Maximum flow rate 59 and bigger than DWF. So is it okay? Length of sewer is 40 meter. Fall is 0.27. Ground level is 25. Upper invert level is 24 meter. Average depth is 1 meter. And for the last is lower invert level is 23.73 meter. That's all from me. Thank you.
So next I will present about the methodology of stormwater management. First step is select the ARI for both minor and major drainage system. Second is divide subcatchment into segment of homogeneous land use or surface design. Next, estimate overland flow times for all other flow components within the subcatchment such as curb gutters or so on. Next, calculate average rainfall intensity for design ARI of Y years and duration T equal to the time of concentration from IDF data from the selected area. Next, estimate runoff coefficient, which is C, values for each segment if there are different land cover. Next is calculate average runoff. And lastly is calculate peak flow rate for the selected area. So for the total catchment area obtained was 14,226.45 meters square or 1.423 hectare. So first we need to calculate rainfall intensity, which is from this we get 348.9 millimeter per hour, and then for the Q we get 1.1 meter cubic per second. So next, for the velocity of flow, we get 2.29 for this calculation, and for the Q, which is drain discharge, we get 0.64 meter cubic per second.
As discussion, when designing drainage system, we choose 10 years as return period because we will be serving an area less than 10 hectares in 2 loops. As addition, from the sewerage design, we are also responsible in designing catchment area. A total of 3 manholes are used in designing the system. The system design is okay as the maximum distance between the manholes are 38.01 meter. The size of drainage that we designed for our project is zero point 0.5 times 0.55. The size of the drainage is acceptable for the project because the flow rate or Q of this drainage is 0.64 meter cube per second, which is greater than 0.02 meter cube per second. So it is appropriate to use this drainage for this project. For conclusion, first, we are able to experience knowledge learned regarding to the subjects and do some real life calculations based on it. We are also able to overcome limitation that our group only have 4 people compared to other group which have 5. We hope that our case study can be used for fellow engineer or our junior as reference because we are the first intake that learn this subject. We also hope that our project may serve as a basis for utilities improvement at the selected area.